For as long as we've had them, the networks that power our entire world have been like these closed-off fortresses. Totally proprietary, totally controlled by just a handful of big vendors. But that's all changing. We're in the middle of a revolution, a massive shift from those rigid systems to an open, intelligent, and, get this, a self-building ecosystem. So, on the one hand, you had the old way. It was this monolithic black box from a single company. Simple, sure, but it was also a total straitjacket. The new way? It's an open, disaggregated network. You can really think of it like a set of high-tech Legos. You get to pick and choose the absolute best pieces from any vendor you want. And while that sparks incredible innovation, it also, as you can imagine, creates a whole new level of complexity. The big driver behind this whole shift is ORAN, which stands for Open Radio Access Network. What it does is break that vendor lock-in by, well, unbundling the network into standard, interchangeable parts, the OCU, ODU, and ORU. It's kind of like the difference between buying a sealed laptop off the shelf and building your own custom PC. You get way more power, way more flexibility, but now you're the one who has to make all the parts work together. And that, right there, is the peril hidden inside the promise. This great unbundling, as some call it, created a brand new monster: fragmentation. Suddenly you've got dozens of standards, countless open source projects, hundreds of vendors, and you end up with 1,000 puzzle pieces that just don't quite fit. It's an absolute nightmare for making sure everything works together. And look, people deep in the industry know this is a huge problem. Here's a quote from Sana Tirik at TELUS, a major service provider. She says they have to improve their CNFs. Those are the cloud-native network functions, the actual applications, and the automation that manages them. They're just not ready for this new world, and they need to get a lot smarter to actually get the benefits of the cloud. So the first big attempt to solve this automation mess with projects like ONAP was to boil the ocean. They tried to build this one massive custom framework to solve everything all at once. The complexity was just off the charts, which created a huge barrier for anyone trying to adopt it. The new approach, embodied by Nephio, is the complete opposite. It's focused, it builds on tools that already exist, and it's born and bred in the world of Kubernetes. And that brings us to Nephio. It's a project that came out of Google, the Linux Foundation, and a bunch of other key players. And it's really the cloud-native answer to all this complexity. It learned from the mistakes of the past and embraced a much simpler and ultimately a much more powerful philosophy. So what is Nephio's core idea? It all comes down to this concept: configuration as data. Instead of writing thousands of lines of fragile step-by-step scripts that break if you look at them wrong, Nephio treats every single piece of configuration as structured data, specifically as a KRM file, which is native to Kubernetes. This one shift turns a chaotic scripting nightmare into a much more straightforward data management problem. So how does this actually play out? It works using a process called GitOps, which is an idea borrowed directly from modern software development. An operator, a human, takes a blueprint, customizes it for a specific site, and then approves it using a standard Git pull request. From that moment on, automation just takes over. It syncs the configuration to the network and continuously makes sure the live network perfectly matches what's in that repository, which is now the single source of truth. Now, the real genius of Nephio is that it doesn't try to reinvent the wheel. It just extends Kubernetes, which is honestly one of the most successful open source projects in history. It uses the native tools Kubernetes already provides, things called custom resource definitions, or CRDs, to define new network parts and operators to manage them. This is what keeps it so simple and so adoptable. Okay, so we've automated the complexity, we're feeling pretty good. But in this open, multi-vendor world, a massive security problem just walked in the door. When any piece of software can talk to any other piece of software, how in the world do you establish trust? How do you know who's who? The answer is a project called SPIFF, the Secure Production Identity Framework for Everyone. The best way to think about it is as a universal biometric passport for every single piece of software. SBIFF uses some really strong cryptography to issue a verifiable ID to every single workload, proving that it is exactly what it claims to be. This right here is the bedrock for building true zero-trust security. Now, you might be wondering, hey, doesn't Kubernetes have its own built-in identity? And yes, it does, but it's not enough. That identity is effectively trapped inside a single cluster. It can't stretch across the different clouds or vendors that you'd find in a real-world Orion deployment. SPIF solves this by creating one unified identity plane that works everywhere, across everything. Okay, so we have an automated foundation, and we have a secure foundation. So what's the next logical step in this evolution? Well, how do we make this whole thing intelligent? How do we make this incredibly complex system easier for us humans to actually manage? And this is where generative AI makes its grand entrance. It basically acts as a universal translator between what a human wants and what a machine needs. So an operator can just state their intent in plain English, like create a 5G core cluster in Paris for 10,000 users. And the Gen AI will generate all the complex configuration files that Nephio needs to go and make that a reality. This just supercharges the entire workflow. The AI becomes a natural language assistant for operators. It becomes a generator for all those complex templates and even code. And it can even act as a smart troubleshooter, analyzing logs to figure out what went wrong. By automating all these key tasks, you dramatically lower the skill barrier needed to manage these advanced networks. And I want to be clear, this isn't just a theory on a whiteboard. The industry is jumping on this vision, and they're doing it fast. The Nephio project is seeing a 40% yearly increase in contributors. That's a huge signal that this move toward open, intelligent networks has some serious real-world momentum behind it. But here's where the story takes its most profound and fascinating turn. The relationship between AI and the network isn't just a one-way thing. It's not just about what AI can do for the network. It's also about what the network can do for the AI. It turns out that Nephio's declarative framework, the same one that's so good at managing network functions, is also the perfect platform to manage the entire lifecycle of AI models themselves. There's a whole field for this called model ops. I mean, think about it. AI models have this incredibly complex and really expensive lifecycle. You have to train them, deploy them, monitor them. Well, Nephio provides the perfect operational framework to automate all of that, from scaling the infrastructure and optimizing costs to managing security, just like it does for the network itself. And what this creates is this beautiful, powerful feedback loop. The network, managed by Nephio, makes running the AI models better, cheaper, and more efficient. In turn, those smarter AI models make the network run better. Each one continuously enhances the other, creating a truly self-improving, intelligent system. And all of this leaves us with a really fascinating question to think about. As our networks learn to build themselves, to heal themselves, and to optimize themselves, what becomes the new frontier for us, for human ingenuity? When the machines can handle all that complexity, what's our next great challenge? That is the exciting future that's taking shape right now.